Right, what's up guys? So today we're doing Google Code Jam round 3. It's starting now. Oh, it started already? Okay. Not yet, but yeah. So let's see here. I didn't do all too well in like round 2, partly because the interface is very confusing. I didn't know there was like 4 problems and not 3. Anyway, so yeah, let's get to it. Can you like okay? Okay, so we have to beat a randomly playing opponent at a game interactively, and we have to beat him most of the time. I hope my mic is on. Anyway. So we have to beat it. We can lose at most one game, basically, for the hardest subtask. Right. So what's the strategy? So if the constraints were small, we could just compute the Grundy values, but I don't think there is a way to compute them explicitly, given our large constraints, or other actually. Let me think about that for a second. Maybe there is a way, right? There should be like segments of equal values. Yeah, I think so. So let's see. Let me just check something. So if the length is like this, and the length is like this, and what are the Grundy values? Let me just go like that, probably. Okay. Yeah. So I'm doing this to check if we can actually go with like finding all the... I'm thinking that the ground values should like change at multiples of 10 to the 10 to the 12, 10 to the 10th, and if that is the case, then we should be able to see it here. See that it changes at 100, then it should change at 200, then 300, and then for some reason, oh yeah, there's a special case, right, for 299, and the reason for that is, yeah, because at 299 you're forced to yeah, with 299 you can, no, I can actually, what happens at 299? Is there a bug somewhere? Why is it different? So we can make a move at 199, which we were able to kind of do before. Anyway, let's see what the pattern gives us. Is it always like the special case? The special. Oh yes, see here we have 598 as a special value, so we don't have the changes exactly at multiples of the length, right? So what happens at here? So here we have all sorts of weird stuff, right? But it seems that it's like bounded by I don't see a reason for 299 to be different, actually. Why is that? Maybe there was a bug. I don't even know. Is there? Why is it different? It is smaller too, so we're forced to. Oh, I see. Okay, so with 299 we're forced to make at least one half have length of 100 up, and with 298 we are, it's not the case, right? So if I were going to make guesses, and I'm probably going to, because yeah, so if I were going to make guesses, then we would have changes at these particular at these multiples, but also at the positions up to 100 positions before that could also be different, because see that here we have some random numbers basically, but they all seem to stabilize after some number. Okay, so yeah, well, what can we do about that? So we have like 10,000 possible values, right? And for each of them we have to determine the move. Okay. By the way, there's some real loud noise happening outside my apartment. Like literally, guys just banging on the walls, literally outside my window. So I hope they don't get too loud. don't know if you can hear them. Okay, can we pre-compute that? I don't think we can, right? Well, we can pre-compute the changes, but are we actually expected to do that? Yeah, we did. No, that's bad. Okay. So we argue that playing inside, yeah, we can actually do something along the lines of, yeah, let's see if the multiples are at most like so it never seems to like destabilize to more than, so we actually need like 400 values. Okay, I think so. Let me check something. Okay, if we have it like that, I'm expecting to have kind of the same values. Yes, see, it's okay, maybe not. So we have to have this. Yeah, well, that seems to hold. That seems to hold. So yeah, now we just have to take this, and then, so if we have a segment, we can kind of map it to a much shorter one, except we have to find the winning move, and well, yeah, I don't know. So it is close to a multiple. What can we do? What can we do? So we expect that to behave the same, and sometimes we need to make a set move, but we kind of can. Okay, I guess I'll just start coding something, and we'll see how it goes. So what's the protocol here? Okay, yeah, so we have the number of test cases and the number of games we need to win, which we don't particularly care about. Okay, so we have games. So we want to in real life we have n equal to this and l equal to this, and then we kind of want to compute the real ground value of a segment of particular length. Let's do it like that. So okay, yeah, if Right, so is at least L minus L, right? So if this at most a multiple, then we have to return the boundary value of x divided by L plus L, x divided by L times L, I guess plus L minus 1, minus the shortage, right? So that would be that. And otherwise we just suppose it's going to be this value, right? I'm guessing. Okay. Okay, so now we need to store the segments, and the only segment we have at the start is, it starts in 1 and has length n. Okay. So does this guy make the first move? Yeah, okay. So we'll read his move. So if we won the game, then we will break. So we assume that minus, yeah, whatever. Except we don't want to have minus 1. Okay, so now we have to so we have to find the segment. Maybe I'm overthinking it, right? It could be that there is a much simpler solution to that. Is there actually? We could apply like a symmetric strategy, but there's no telling if it works. Like, what if the guy covers the middle? What do we do then? It's not clear, right? Okay. So if we have so he covers these. In fact, so okay, and also so that's the position of the last one. That's the position of the first one, and the one. I'm guessing. So keep that. All right. So what are we doing then? So we can compute like the total running value. And if we win, then well, we can find the winning move, and otherwise we just make a phantom move, right? We just hope that the guy makes some mistakes, basically. And in fact, we can even forget about the segments that do not have any valid moves. So let's just shuffle the segments. Yep, and then we output like the first. We don't exactly care what happens then. Okay, so how do we find the winning move? Okay, so let's go back. Yeah, so otherwise we know how we want to split the segment, and then we just want to see if we can do that. Okay. So if we fix like the align length of the left part, for instance, seems like we can always make it like could be, yeah, right. I'm guessing, but okay. So we want to store all the options, or in fact we don't even need like compute this. I'm guessing. No. Yes. Okay, now we just sort of try all moves. Yeah, but then we have to kind of align, kind of make a move. I'm not really trying too hard, as you can see. So after that, we should have found the move. And we print it. Oh, that should be like that. Let's get rid of that while we're at it. Random shuffle. Right. Yeah, so if you can tell, what we're kind of doing is, yeah, you know, we're trying to play the game optimally, assuming some sort of hypothesis about how the Grundy values behave. Basically, we only look at like maybe a few thousand interesting values where we assume that it's going to change. Can I have like yes, iterative runner. Okay, so how do we go about that? Does it work? I can't really tell. Yeah, let's flash the line. Maybe that was the issue. So, assuming everything works, I'm expecting to see something, but I don't see anything. Yep. So how can I see like at least what I'm given? Is there any kind of interaction going on? There's always I don't know what the issue is, but yeah, see, I'm not getting anything basically. What sort of does it even work? I'm sorry. Where are you getting all this input from? Yeah, see, he plays the thing, but shouldn't. It doesn't play things, but it tries. So, assuming that we make a move, so we make a move as well. I don't know. Let's type a random move. Yeah, we type a random move as well. So the interaction should go on, but it doesn't. For the reason I do not really know. Yeah, that happens a lot. Well, with my hold on. I think I know what the issue is. But I've been getting like some issues in the past with in the past runs with these like testing tools and stuff, because sometimes they just do not run and you don't know why. Yeah, what could I fix? So you cannot fix it here, can you? So see, I don't even know what's going on, why it does not run. I could try to like implement some interaction myself, but I don't know. So there's something happening. But how can I like how can I determine what goes wrong? See, I wasted so many time on that, and I can't even see things. Maybe it works, maybe it doesn't. There is no way to tell, basically. So let's try it one more time, and it does not run. Maybe we should try like a different Python. Yeah, see, it doesn't work. Well, what happens? Why it doesn't work? Oh yeah, you have to type in the test number. Okay, so let's type in 0. Does it help? Not really. If we get rid of that, what happens? So it looks like it fails. So we try to make an illegal move, and it does indeed seem like a legal move. Okay. I see the problem. Is it better now? You tell me. Do we still make illegal moves? Yeah, we still do make illegal moves. Why do we do that? Do I misunderstand the problem? So this does not seem like it's an ending position. It seems like this should be the ending position. So yep, it shouldn't change things, but we still make illegal moves, right? Yeah, the exact same name, in fact. So we did make mistakes. Okay, how about we do not erase everything? Not sure if it helps. It does not. So we make a move after an illegal move after and okay. Oh, I mean, it's not okay. What can you do? Oh yeah, we are probably trying to make a lot more moves than necessary. Now, how many games do we win? So we won everything. That's good news. Did we win everything? Okay. So it seems like it's working, and we're kind of free to submit. Let's try it. So I'm trusting that let's see what's going on here. Is there problems that a lot of people solve? Can we have like statistics? Okay, that's sort of statistics. Yeah, thank you. 9% failed and 9% solved the actual problem, which is good to know. And so it seems like people are solving. So what happens here? Seems like people are solving the second, and this my submission is still judging. Okay, so it's still judging. I hope we don't get like time limit or something, because I do some work. Okay, so a traditional problem of Google Code Jam, it's about pancakes, which we had a bunch. Do I have a camera on? I don't have a camera on. Okay. Do I do it like that? Okay. Sorry about that. Not having a camera. I don't know if it adds much, but anyway. So it happens here. Okay, it passes. Right. And where does that put us? 40. I think like 25 people pass. Okay. So reading the second problem. Okay, so we are removing the stacks from the left and from the right, so that at least 3 stacks will remain. And the sequence has to look like a pyramid, basically. So we are given an ostensibly long sequence of pancakes. Yeah. And we have to sum these things, right? So we're taking all possible subsegments of length at least 3, and then we need to find how many pancakes we need to end, so that the segment that we chose becomes like a pyramid, right? So all of these inequalities are satisfied for at least 1G. Right, so okay. So if the segment contains the largest stack, right, it never occurs to us that we have to add something to that, basically. So what we can do is we can consider all segments containing that and sort of go to the left and to the right, and yeah, let me try and draw it. I'm not sure if this is the correct one or not, but yeah. So never mind that. So if we have these stacks, and we have the largest one, if we assume that our segment contains that, then, well, let's make it slightly larger. I cannot erase. I don't know if I can erase. Anyway, so we can go to the right, and our approach is if there is a stack that's higher than something to the left, then we have to like make it larger. Okay, so at any point we have like this stack of values, basically. Okay, so and then we can kind of divide and conquer, right? So we've processed all the subsegments containing our largest guy, and then we solve this problem for the left and right in the same way, finding maximum and so on, yada yada. Okay, so we have 30 seconds for that. We have 30 seconds for that. 100 cases. Okay. So we have to do an RMQ, right? Because we have to find the largest stack in the current segment, and they are changing, so we cannot like cheat and stuff. We can go with segment tree or with sparse table. I'm not sure which is going to be faster. Probably sparse table is faster to code. So we have that, and then we we cannot do that. We cannot do that, can we? Because we process the segment in linear time, because we have to do all the passes and stacks and whatever. So we cannot exactly do that. Okay, that makes sense. So we have to be kind of clever about how we merge stuff, don't we? Okay. Well, I mean, we can do like the same thing, but the other way, right? So instead of going from the largest segments, we start from segments of length 1, basically, and we process them by increasing of height. So if we have a stack of current height, then we have to take the groups that are to the left and to the right of them, add something to the answer, and then combine everything into a large group. Okay. So what information we need to maintain? Well, we kind of want to maintain this stack, right? But we need both stacks. So the increasing one and the decreasing one, and also the answer. But yeah, since this is the largest guy currently, what we have to do is we have to take this stack here and then add this guy to the answer. And then add something here. Yeah, so that seems pretty simple. So how do we go about writing that? So we sort all the numbers. Then do we need to store stacks? I believe we don't need to store stacks, right? We just need to store like the total answer. So the total number of pancakes we need to add. So in order to do that, we need to store like the sum of numbers. Yeah, that seems easy. Give me a sec. So we could go with GSU, I believe, because it's like it won't take any time. We don't need the sparse tables or segment trees or none of that nonsense. And we also need to store a bunch of numbers, right? Okay, let's do it like that. Can all the numbers fit into them? We have to do it modular, so it's not really important. Okay. So the number of like stacks, the total amount, and also the sums to make the increasing one way and the other way. And what I'm going to do is I'm going to write this small operator here that will like encapsulate everything I want to do. Except, well, I need to rely on the fact that one of the guys is largest. Yeah. Maybe it's better to do it manually. I'm thinking it's better to do it manually. I'm going to keep the structure though. Okay. So, as usual, we have these test cases, yada yada. It starts with T, so we go with T as well. And we also need, let's just store the numbers for good measure. So, let's just store the numbers. Then we initialize the structures by like that. Is it going to work though? It does seem to work. Okay, so now we sort the numbers, right? We also need to initialize our GC. Now let's make a list of all positions and sort them by increasing all the numbers. Okay, so now we process everything in the order of increasing. Let's maintain value for the answer. Okay, so now our guy is currently the largest. Yeah. So we want to merge it. Let's do this Visual GSU thing. With path compression. As easy as that. And then we want to merge stuff, right? Now, since we can have equal values, we have to be kind of careful, because our guy could be already glued to another group. Okay, we could just compress that, but let's just do it like that. Okay. So what we're doing now? So we have our guys here, and we still need to maintain where the largest values is, right? Or do we? We don't, do we? We just have to take that value. No, I'm getting it wrong. It doesn't work like that, because so the guy is the largest, but we still have to do stacks. And we have to maintain the sums of answers for all suffixes, basically. Okay. Okay, you know what? I'm going to give it a quick thought, outside. So hang on, and I will be back in a few minutes. Hopefully the camera is off now. Right. Okay, I think I know what to do now. We need to store like 2 sums. 4 in fact. One sum is going to be the sum of, so S1 is the sum of values on top of like oh, we also need to, okay, so one sum is going to be, can we, oh, how do we recompute that? Anyway, one sum is going to be like the smallest amount to make everything like non-decreasing, and then S2 is going to be the same thing, but it's the sum for all prefixes, and RS is going to be the opposite direction. Okay, so it's easy to compute the total number of pancakes like that we need to have, but how do we compute the total amount of things we actually need to put on top? I'm thinking that we can just subtract things at the end, so we don't need to count that. And now I'm going to do this right again, except we're assuming that the largest element A is in the middle. We're going to update it. I'm just doing it for convenience, whatever. Okay. Then I'm thinking we need a model here, because everything is model something. Let's check. Okay. And then we have to update things down here. So this is easy. This is just, we make the first part non-decreasing, and then for the rest of it we're going to use 8, and that's going to be how many? Our length, right? Because everything in the right part is going to be like that. So RS1 is just symmetric. Okay, and then about that we're going to do some, so okay, we have LS2, and then we have r.len different prefixes. For each of them we're going to put ls1, but also we're going to put like 1a, 2a, 3a, and so on. So that's like the sum of, I'm thinking, like that, and that's a, and that probably does it. And the same thing goes for the opposite direction. Just let me check that I don't mess this up, because I need to update the values with some care. Yeah, it seems like it does it. So I'm going to use that. Is it important? The order is not important, right? Okay, so now we have 6 values. So that's going to be the number of pancakes that we have, right? So we're making it like that, I suppose. Okay. So how do we actually compute the answer? So the new segments that we introduce, first of all, let's do it like that. So how much does the answer get? The answer gets so we get some prefixes, so it's the sum of all prefixes times the okay. I believe it goes like that. Okay, so now we have ls2 times r right? Why did we need the sum again? Do we need the sum? Anyway, so that's how much, and then it goes another way. rs2 and then I'm thinking plus r, and then parent of the root of I is equal to, and then the same thing goes for another half. And what changes is almost nothing. Be careful here. Okay, so now we have the answer, except it's not really an answer, isn't it? Because we have to subtract something from the answer. Did I mess up? I didn't mess up. Okay. So now we need to subtract from the answer number of pancakes that are actually there. So that would be I times, I'm guessing plus 1 would be, times n minus I, that would be again, and I guess that does it. Let's see, how do we do on these sample cases here. Well, we don't output anything. That's nice. That's nice. Why don't we output anything? Do we? Oh, because it didn't compile. Okay. And it didn't compile because there's a semicolon, and it didn't compile again because of reasons. So that should do the trick, I guess. So we have some nonsense in the answer, and that's fine. Okay, so now to find the error. And so what do we have here? That seems correct to me. Let's seems correct to me as well. Well, what did we miss? Okay. This seems correct as well. So what do we have as an answer before we subtract things? Well, we have something that looks like an answer, except it's too small, I'm guessing. So as we are gluing things, we didn't exactly account for the segments of length 1, did we? So let's do that. I'm guessing it should be better now. Is it better now? Not really, but that's fine. So what's the answer is supposed to be? So it's going to be 5 plus, like, yeah, it should be more than that. Should be more than that. Okay. So we're gluing things. We are gluing things. We are gluing things. Oh, we don't update anything. No, so let's do it like that. This is probably going to make us update things. Will it? Yeah, that's only slightly better. So we have the correct answer for the first case, and we don't have any kind of correct answer for other cases, because as we only have to glue if the number immediately to the left of us was not updated before, is it? Yeah, because I mean, if it was updated before, right? So let's introduce some more correction to the program. So I'm guessing some of these is not necessary, but let's see what that does. So it makes everything incorrect. Makes everything incorrect. Okay. Okay. Does it even work on like the simplest case like that? Well, it does, but it does not really tell anything. See, this does not work. Okay, so what does it do? I'm not sure what it does. So initially we process like 1 and we don't do anything. Then we process 2 and we glue the answers for 1 and 2. Then we process 3 and then we glue 1 and 2 to 3. So where does it put us? So initially we should have 2 cases of gluing something. Okay. For 1 and 2 the answer is yes. And then as we process 3, we somehow add 10 to the answer, but that's like 1 more than we need to. Why did it stop to work? I'm not sure. I'm not sure. Okay, so what do we have now? Okay, so for 1, 2, this seems correct. So for 1, 2, 3, this seems like it's correct as well. Yeah, so that seems fine. That seems fine. Why do we have like 19? So here to the answer we add like 4 times 1. Oh, okay, I've messed up these, so it has to go the other way around. Righty, so is it better now? So 1 is not correct as well. Is it? I mean, we had like increase in stack, so okay, so we add 12. Why did we add 12? We needed to add like 5 plus 6. So RS no, I think it was correct, wasn't it? Yeah, it was correct. It was correct the first time. Okay, so we had 3 and we added 3 times 1 plus 3 times 2. We were supposed to add 3 times 2. What did we actually add? RS2. Yeah, that wasn't supposed to happen. We were to add no, let me think for a bit. It isn't correct, is it? Because no, okay, so we were going to add 6 times 1. No. We were going to add 4. I'm missing something. We have to sum over all suffixes the answers of making them non-decreasing, and I'm doing it the other way around right now. Okay, so we can fix that. So the suffixes, to make them non-decreasing. Okay, fine. So what do we have to compute exactly? I'm thinking we start with that. And then all the other guys. Oh yeah, I see the point now. Okay. And then we add, let me write that. We add the same thing here, right? Except we now have a bunch of A's to the right. Okay, so how many? That would be 8 times 11. I'm guessing. Yeah, that seems correct to me. So why do we need that? Do we need that? Not sure. Okay, so now for the prefixes, to make them non-increasing, I guess. RS2. Is it just the same thing? Do we even need that? We probably don't need that. So do the cases work now? I mean, if we get rid of the trash, do you have the correct answers? Because it's hard to tell right now. So it should be 1. No, it shouldn't be 4. It shouldn't be 4. And that answer is correct. Okay. Well, that's something. Okay. Okay. Well, it didn't compile because I had it wrong. Well, that's not going too well, I have to say. So why 4? What does 4 do here? Are the formulas even correct? I have a feeling that I'm missing something. Okay, so we're making prefixes like that. So ls1, ls2 corresponds to, let me think about it, suffixes that are not decreasing, right? Okay. Okay. Is it just that? Is it just that? Oh yeah, we have to... Wait, what? So the number... What? Why are these equal? They shouldn't be equal. Does it make sense? It doesn't make sense. No, it doesn't. So we're making I just don't get it. Yes. I'm getting that the strange thing that the formulas should be the same, but it shouldn't be the same, obviously, and I'm trying to figure out what the error is. Where is the error? Give me a second. The article, probably. It's really weird, but we don't actually need two formulas, except I messed up and I should have written it like that. But it seems to me that they're just equal. So yeah, that probably means that I'm missing a lot of things about the solution, but it seems to work, so I'm going to roll with it and just submit the problem. Do I want to run it? I don't really. Yeah, so let's see what happens with the problems. Out of these, So if I'm passing this test set, I'm probably passing this because the time limit seems fine, the memory limit seems fine, and yeah. I'm not sure. What about nonce? I've seen these nonce before, like in the previous rounds, and they still didn't fix it. It doesn't make sense to me. Okay, so we have an hour, and we have 2 problems to solve. So this is now like a sort of gamble, which of the problems to tackle, because you see the last problem is worth like a whole ton of points, which means that it's, first of all, it's really hard, and second, since it's hard, it may not be enough time for me to solve it. But it could be that I'm lucky and I just the idea is appealing to me, or I've seen a similar problem before. So I'm going to read both of them and see what I can make of it. Maybe I'll like one more than another. Okay. So we have like matrices of zeros and ones. Okay. Okay, interesting. So we have this matrix basically of zeros and ones, right? And we consider the connected components of zeros and ones, like 4 connected, so in cardinal directions. And in each diagonal, in each like common corner of 4 cells, we can draw one of 2 diagonals. And we want to make it so that all zeros are connected and all ones are connected. And you can see that sometimes it's impossible. For example, in the test case here, we want to make like 4 components connected, but we can also only draw 1 diagonal. So, that looks like an interesting problem. I feel like sort of spanning tree vibe here. It doesn't seem too obvious. So that it could be that the game now, so if you look at the scoreboard, we can see that no one solved 3 problems. Did anyone do anything with the first problems? Okay, so yeah, now there are solutions for 3 problems. There are actually a bunch of them, right? So the game now is to, I guess, get the one of the problems correctly, like to the full answer. Okay, so what about the first problem? It shouldn't be too much of a time waste to read that. Okay, so a polygon Ooh. So we divide a napkin into things. What? Okay, so we have, I believe, what we have. Let me see here. Okay. Right. So we have a polygon, and we have to draw like at most 10 lines. We're given the number of yeah, we have to divide it into a number of parts with non-intersecting segments, so that each segment, like if we consider all the k parts, so 2 parts adjacent to each line are symmetrical with respect to that line. And yeah, it could be a path like that, but it could also be a tree, right? An arbitrary tree. So if that segment was here, if that triangle was here, and we would have these as a segment, then it would be fine because it would still be symmetrical. Wow. Okay. So that does seem like a hard technical problem with a lot of cases. And even if I came up with a solution like right now, I would probably guess that it would be really technical to implement and I wouldn't get it in time. So I'm probably going to try and focus on the third problem right here. I wouldn't favor my chances to qualify at this point, because there are so all these people didn't solve the first problem, and there are not a lot of people who solve 3 problems. So if I solve the third problem faster than all these people solve the first problem, then my chances for qualifications are non-zero, I guess. So yeah, it's important for me right now to solve this problem quickly. So what I'm going to do is I'm going to think a bit on my own, if you allow me for a moment. I'm going to tackle this problem, and this problem is not for me probably, except if I want to get the small test set to get a subtle edge on people. Okay, so be right back. Okay, so I have an idea, which is basically there are simple criteria for the answer to exist. Let's see now. So first of all A's and all B's must be like 8 connected, because otherwise there's nothing we can do. And another thing we need to check is that if we look at the border and like travel along the border and count how many times the color changes, then it should be only 2. So you see here, along the border the color only changes here and here, and here we have 2 color changes as well, but here we have 4 color changes. So that's bad, because it means there would be 2 intersecting ways, 2 intersecting chains of diagonals. And that's bad. And otherwise, if there's only 1 color change, then I presume we can just build a spanning tree with respect to 1 component, and that will give us a solution, because there will always be a way to connect everything else. Yeah, and if everything is enclosed inside of the first component, then it's fine, I guess. At this point I'm willing to just write a solution. I'm pretty sure it goes something along these lines. Okay. So we'll need another of these here. Let's make it simple. So first we are having our 4 connected components, because it's going to be easier to build the spanning tree that way. Right, so now we have to consider the diagonals. Okay, so I'm willing to assume that we just build a spanning forest of the thing. And we also have to keep track of things not intersecting, so do we actually need to do that? Because we're just building a forest, don't we? So we probably don't need that. Goes this way. No. Okay. Otherwise, incorrect. Otherwise, we go the diagonal the other way. And unite things like that. Okay, so we should be good. And now to check if this is what we were going for, we just have to count the number of connected components. Why did it do that? As a matter of fact, why did we didn't even need to check for that in the first place. I'm willing to think. I'm going to leave this. Is it guaranteed that there are always at least one A and one B? It's not guaranteed, so let's do that. Copy pasted a table. That's nice. Okay, so did it work? Presumably it did. So it built these things. Do I just submit now? Do I want to test it in any way? I'm going to bite the bullet and just submit it. So we have 2 test cases. I'm willing to believe that if we're doing good on the first case, then we're doing good on the second case. But you never know. It's the wrong answer. Okay, so we get some penalty. And now we get to think about what we've done. And we've done bad, so there is a typo. Am I willing to submit again? Yes, of course. Am I willing to double check what I wrote? That as well. So that was slightly better. Yeah. So yeah, that was a typo that just renders my solution completely invalid. I didn't check the part about the border, did I? Anyway. Okay, so that passed. And do I want to double check anything else? I probably want to get the small test case for this. Okay, so I have a polygon, and what I want to do is to just cut it to find like a bisector, right? So that bisector is going to be either mid-perpendicular to a side or a bisector of an angle, isn't it? Yes, it is. So that means that I just need to check those. N is small, so I can do it like in quadratic time. So it has to be good on both sides, and the rational coordinates are not a big issue for me because I can just multiply all coordinates by 2, can I? Sure, let's do that. While I'm at it, am I willing to think about the full solution? Am I? Yeah, I could try all trees. Probably. I don't know, do what exactly? I'm not sure. So if I have a leaf, and it has to be like on the border of things, isn't it? And so what that means is that the side that I'm cutting is going to be, you know what, never mind that. Let's just solve this first instance real quick. Okay. So we have N and K. And checking for symmetry is actually really simple, I'm guessing. So the usual geometry stuff, yada yada. I don't even have to think. Right, so how am I going to proceed about checking stuff? Also that, I guess. Okay, what about bisectors? What about them? But the bisector, we only need it if the adjacent sides have equal length, so we can just take the sum of the sides. So that's not an issue, except we need to compute the length somehow. Sugar. Okay. Being extra careful here. Okay, so right. You know what? Just to be real safe. As a matter of fact, I may do that. Okay. So now we need to check stuff. First of all, we need to check the mid perpendiculars. Right. So that's one point. And the vector in question can be is just rotation, isn't it? How about okay. So we need to try that. Okay, how do we do that? First of all, in clockwise order. So, and what is this rotation? So y minus x, it's probably counterclockwise. So we want it to be clockwise. Okay, so now that points like inwards. Yeah, and so now we need to check if this is actually what we are looking for, and to do that we need to see if for every point there is a mirror reflection of that. Okay. Okay. It's even simpler, isn't it? We start at like, how about we go like that? go in opposite directions. At most I can or something. Yeah. And we can maintain the other point. So we need to check if that other point lies on the same. So we basically go like good and equals minus m percent n equals 0. So if it lies on that. Okay. So if it's good, then we say that CA is m and O is and C is O, and we break. And otherwise, well, that's one side of things. If we still didn't find anything, then we kind of do the same thing, but now look at that. Yes, and then we kind of do the same thing. Except now we start from equal points. Yeah. Okay. So if it's okay. Can we have like negative coordinates? No. We have well, let's make it print. Do we need to do it like that? Yeah. Okay. So we have a bunch of cases which may or may not correspond to anything. No match for what? I'm sorry. I'm sorry. You didn't know what n is? Why are you asking me? Why are you asking me things? So n is a point. You're not wrong. Okay. So let's make it, I don't know, g. So now we have D here, and D here, and D here as well. So that should do it. Okay, what about, I don't need the outputs, thank you. And I don't need neither of that as well. I just need these. Okay, so we're getting nothing. Because we're not changing the coordinates. We should probably do that. What? Are you worried about that? I'm not worried about that. Okay. So, is it even correct? So we have this square, this little square, and we cut it from, yeah, we cut it just along the half of that. Okay, can we have a picture? Yeah, that seems fine. There are no patterns, and here it's possible to do it like that, I'm guessing. Okay, so that seems good to me. Let's see if I can get it accepted on the small. Yeah, I can select language, thank you. So let's see if this works on the small case. I'm hoping it does, because why wouldn't it? It doesn't. Okay, that's fine by me. So let's see here. We did multiply coordinates by 2, didn't we? Okay. The rotation is not very important. This is not very important as well. This should be fine, I guess. Can we have like consecutive points? Can we have that? We can, and I don't like that a lot. So we first need to fix our polygon. That could be an issue. We cannot have an equal to 2, can we? No, we can't. So this should work now. even if we like introduce some points that are not supposed to be there, like this. Yes. It didn't work before, and I'm not sure that I read the complete statement for the fact that there are no nested vertices on the sides. But nevertheless, we'll see if it works. So it gives. It's still pending, and it's still wrong answer. Okay. Okay, I can take that. No, yes, okay. Did I miss something? So they have to be symmetric with respect to f. Yeah, that's exactly what I'm trying to do. That's exactly what I'm trying to do. So let's read the code real quick. Now that stays here because I'm worried about it. So now let's check things. So regarding the logic, the bisectors and mid-perpendiculars seem correct to me, right? So how we dealing with that? So we take the midpoint of these two guys. We are starting to check if the other points align, and we probably can't get any like range errors, range checks. So that has to lie on the... But does it mean that they are symmetric? It doesn't, does it? So in addition to that, we should probably check stuff. Yeah, it doesn't mean check, basically. So in addition to that, we have to check that like the distances are equal, because if the distances are equal, yeah. So that was a kind of a weak check, but that should do it, I'm guessing. Okay, so that's out of the question now. Is there anything else? I think not. My output format seems to be correct. We have to go with like these non-reducible yada yada yada. Let's just submit that. Yeah, that was a blunder on my part, because of course that's not enough. Of course that's not enough. And I did a blunder again. Oh my god. Oh, I don't need to do that. I need to... Wow, okay. Okay, that's getting ridiculous at the moment. That's going to be the wrong answer, right? Yes, I know that. I know that. What about now? Is it better? Oof, okay. So now it should be fine, as long as I didn't mess up anything here. Okay. Whew. I'm ranked 12th, which doesn't really tell us anything, because yeah, we can't really tell. What about the total penalty? Can we see the total penalty? Oh yeah, this is a record pace right here. Okay, so if I were to speculate, a bunch more people are going to get above me. Like I'm going to end up maybe in high 20s or something. And at that point, all I need is that all my large subproblems pass. Except for the last one, because that's totally not working. Yeah. So the second problem, I'm willing to believe that if that passed the small problem, and is going to work on the large one, as long as I don't have any integer overflows. Let me check for that real quick. Okay, so can we have an integer overflow? So we're being like, so this is small. This never takes any part in anything at all. This is like computing the same value twice for some reason. And I don't see any overflows in particular here. Yeah, that seems fine. So what happens over here is all of these are taking modulo as well. So I'm guessing this is not going to be an overflow. Probably, fingers crossed. Here we shouldn't get anything either, and we're taking care of that. So I'm willing to believe that B is going to pass. Concerning C, again, we got the small subproblem accepted, which is good, because, well, it gives some confidence about if it's going to if it actually works or not. But it could be that all the that there are some tricky cases that require large dimensions. I think that I got a fairly good justification of what happens. So since we have some time left, let me draw some pictures real quick. So okay, so we have this matrix, right, of zeros and ones, or A's and B's. So I argue that I don't use it in any way, but I argue that if we have a situation like that, like you see how the border consists of like more than 2 consecutive segments. So these have to be connected, and these have to be connected. So it could only be like, if they're connected, there's a path here. It may use some diagonals, but these paths here, they are bound to cross somewhere, right? And the only way that they can cross is if they use the diagonals that are actually the same point. So that's not allowed. So I argue that if this happens, then the answer is just no, right? And another part is that if we have situation like that, where one part of the border is just A's and the other is just B's, and then we have some connected components of A's, 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 and then probably B's, B's, everything else is B's. And if we build any spanning tree of A's with these diagonals, it could never be that we, like, provided that all A's are for 8 connected and all B's are 8 connected. I argue that there is no way that by doing that, if we build a spanning tree on A's, then we actually cut off all the B's. So why could it be that some of the B's were previously 8 connected, but now they're not? So what that means is that there is some portion of B's that are now enclosed in a cycle that we've created, because it wasn't present before, and it's now enclosed in the cycle, but we didn't create any new cycles because we built a tree. Okay, so if the solution existed, then we might as well like build a spanning tree of any kind of spanning tree, it doesn't matter, and then any spanning tree on B's, and they're not going to intersect because of this argument. And that's exactly what I do. I basically just build a spanning forest of the graph. Actually, this check is not even needed, because it will handle that automatically, because the answer does not exist, so we won't obtain it. Right? So we do that, and then we just check if this actually gives us like at most 2 components, right? So that's the straw. That I might be missing something, but that leads me to believe that it is a correct solution, and of course it works fast enough. It works like in linear time. About G, I got all I wanted. Except for the penalty, I didn't really want that. So I am already ranked like 16, right? Which is bad. At this pace I'm going to fall out of the qualification threshold real quick. I could hope that someone fails something, but I don't see any real way to solve any of these 2 problems, and like solve the easy case and not solve the hard case, especially for all of these guys. I'm willing to believe that all of them did a good job on that. Yeah, so that was a thing. That was the same. Oh, there is a number of contestants that attempted the problem. Okay. And probably this means something too, but who can tell? Oh, they fixed the percentage. Holy. Okay. So we can see that here lots of participants are struggling with winning lots of times. I don't really know if there is a way to do that without like trying to play optimally and waiting for the random opponent to make a blunder that you can exploit and just make random moves while you think that you cannot win optimally. Here and here a lot of people are getting accepted like the small case, and are probably going to accept the large case as well. Here I'm probably like one of the only people who made a blunder on the small test case. With a case that I forgot to check. Yeah, so could I explain some things in more detail? I did explain the 3rd problem. I kind of explained the 2nd problem, except not really. Right. So in the 2nd problem, we are thinking of the largest stack, okay? And let's consider the maximal group of smallest stacks to the left and smallest stacks to the right, okay? So when we introduce that, prior to introducing this stack, we are thinking of these being 2 independent groups. So what we do when we create a group is we count the number of the total answer, the sum of answers for all subsegments in the group. Okay, so we are going to make this well, first of all, let's make this a whole group. So when we make this a whole group, we introduce a bunch of new segments, namely the ones that end here and start somewhere over here. Okay, so what's the sum of that? So since this is the largest, it's going to be a non-decreasing. So we have to sum the answers for the suffixes of the segment, and also introduce this one into the answer for each segment. So it's like the answer for the left half, let me write it down, plus the height of that times the length of this part. Okay, and now we're going to merge this. And again, since this is the currently largest stack, we can tell that this part is going to be non-decreasing and this part can be non-increasing. So when we merge that, the new segment that we're introducing all start somewhere in here and add somewhere in here, and these parts are kind of independent, right? Because we just, if we take a prefix here, then what we're doing is we're adding the smallest cost to make it non-decreasing, right? And we need to sum that for all positions here. So the sum of like non-decreasing, and here we do the same thing and we multiply it by the number of occurrences of like this start of a segment, so it's times the other length. My handwriting is just beautiful. Let me see if I can find a better pen. Yeah, that's better. Okay, but now as we merge that, we need to update the sum of, we need to update this, right? The new sum of smallest way to make this non-decreasing. But since this is the largest one, so we sum over all suffixes, right? So some of the suffixes are accounted for in this sum, so we just add the answer of that. What about these answers? You can see that this is the largest one, so if we want to make a suffix like this non-decreasing, then we make this suffix non-decreasing and then add a bunch of h's after that. Okay, so it's like we have to sum over n strike, but also we have like len strike of these prefixes. For each of them we're going to add len times h to the answer. Okay, so this is the new formula basically. It's not really formal, but I just wanted to illustrate the idea. And you can see that the formula, quite interestingly, is symmetrical. So the answer for the non-decreasing suffixes and non-increasing prefixes is the same. And that kind of bothers me, because I don't see very simple justification for that. It could be that there is a very clever observation. There probably is a very clever observation why that is true, but there you go. It works. And so to merge the groups, we maintain the GSU. We could do with faster stuff, but I didn't bother to do that. And sorry. Do we even need the GSU? I don't know. Anyway, for the group, well, we maintain all these numbers. We basically only need the length and the answer, whatever that is. And about the first problem, we kind of assume things. So it's like the standard problem where you have a segment and you're allowed to cut out portions of length out of that, and you play a game, and whoever cannot place a new segment, he loses. And this is a standard application of the Grandie theory, because we can compute the Grandie value of a segment of length n. So as we know, the Grandie value is the max of Grandie values of all moves. So let's say that the move is parameterized by this length. Let's say it's I. So it ranges from 0 to n minus l. And after we make the move, we have two independent games, right? So we are allowed to XOR the Grandie values. So it becomes Grandie I XOR Grandie of n minus I minus l. Okay, so this is the formula, and with this formula we can compute the Grandie value of any segment in n squared time, because it's just simple dynamic programming. Also, what happens here? Do we have the final results? I am ranked. Oh, okay. So I did qualify. That's nice. That is nice. Perfect. Well, that could have done slightly better. Yeah, it's a good thing that I got the that small test case accepted, because otherwise the chances would be like not 100%. Anyway, so it's that. But in the problem we have a very large n and a very large l, so we cannot do that. However, we can think of it like that. If we look at the values, when we think about n, if it doesn't exceed l, it's always 0. And when we are considering subsequent moves, so we figure that the answer, that these values form very few groups of consecutive numbers. And in fact, the next group is going to be from L to L minus 1, I'm guessing, because it's the range where someone makes a single move, and then it's a loss. So you would expect the pattern to continue. However, this in each segment, so we have at most 100 segments of that, right? Because n is 10 to the 12th and L is 10 to the 10th. So we have at most 100 segments of that. So at most 100 groups. However, it could be that at the very last, like the last about, I am going to say 40 of elements in every group can be like root, can be random. And I explained something about that before, but let's see why 3l minus 1 is special, why it could be different from 3l minus 2. So in 3l minus 1, however you move, at least one of the halves is going to be at least l. And that's not true for 3l minus 1, for 3l minus 2. So you have a different set of moves, like non-equivalent moves, if we consider the positions in the same range to be the same. So we have these special positions, and that gives us about 4,000 like interesting positions. And then we can only consider that and basically use the n squared approach to compute the Grandie values. And then to play the game, you have to do some you have to like go back and forth between the ranges and the actual game, and you have to find the winning move optimally. I'm not sure if there is a better way to do it than that. Since the problem is not worth a whole lot, I believe the authors had some simpler things in mind, but well, I did it, so who cares. So anyway, that was fun. I didn't find the problems. The first problem was kind of, some people call it like random problems, where you have to make an observation, or you have to like find your own approach to the problem. The second and third, I would say, were quite standard. The fourth, the small subcase, was quite standard as well, and the last case I'm pretty sure no one solved. Yep, that is as expected. Is it a good round to eliminate people for the World Finals? It works. I mean, there's not a whole lot of people who got all of the problems accepted, right? So how many people did get at least 57 points? See, not a whole lot. Like less than 40. So yeah, people were struggling with all sorts of things. I believe the first problem was like a major issue for a lot of people. So yeah, not a fan. Wasn't okay round. I got advanced, so who am I to like be whiny about that? Anyway, so that does it for today's screencast. I was lucky that the repair guys outside were not giving us too much trouble today. Yep, I guess that does it. Thanks you for watching, and I'll see you next time, hopefully. Right, bye.